Today I would like to tell you something about my research. And I'm a fundamental ecologist. I don't work in agricultural systems, but I work in natural ecosystems like the one you see on the back here. And this is a tundra in the north of Sweden. Although I do fundamental research and I work in ecological processes in natural ecosystems, like Richard Barges said this morning, I think we can learn some important lessons from these ecosystems and may apply them to agricultural systems. So I would like to tell you one story of the research I'm currently doing. And this story really has two phases. So first of all, it's about home. It's a story about the place where you feel fine, a warm place where you want to be, and basically a place where you really function optimally, your home. On the other hand, it is a story with another phase. It is a story about death and decay, a story about rotting leaves. I focus on plants, so plant litter, and about the nutrients that are basically kept inside these leaves. And those nutrients are valuable for next generations of plants to grow. So we need them to be released at some point, and they can be used by the plants and taken up and used for growth. And this is one of the most fundamental ecosystem processes on Earth. Here you see it sort of depicted in a scheme where like leaves fall on the ground, they enter the soil food web. In the soil food web, they get decomposed first by invertebrates and later on by microbes, such as fungi and bacteria. And the nutrients inside them get released and can be used by the plant roots, and the plants can use them for growth. Because this is such a fundamental ecosystem process, it has been studied really, really intensively. And we know the most important drivers really well. And there's three basic fundamental drivers of decomposition processes. And the first one is climate. The moisture and the temperature of the environment are driving the rate of decomposition. The second most important driver of decomposition is the quality of the litter of the leaves that you put into a system. So basically, if plants are really recalcitrant, they have a lot of compounds that are hard to break down. Nutrient cycling and decomposition is very slow. Whereas when plants have a lot of labile compounds, things that are easily to decompose, nutrient cycling is relatively fast. And then finally, and probably most importantly, there's biota that actually do this. They break down the litter. And even though these are the guys that do the job, so mainly in the end fungi and bacteria, we know very little about them. We probably know least about them of all the things we know about decomposition. Can they function? Can they change in function? Can they specialize on different litter types? And can they sort of optimize the nutrient cycle? Over the last 1 decade, 15 years, ecologists have started to study this in natural ecosystems, and they found indeed that decomposer communities seem to be adapted to the litter type that they receive. So what falls onto them is basically what they can decompose best. And here you see that. So if you fall right underneath a plant where you originate from, you sort of get decomposed more efficiently than when you fall underneath another plant where the specialized decomposers are lacking or absent or not yet adapted to your litter type. And this process is called Homefield Advantage. So you do better at home than you do somewhere else. That's the idea. And this is something that was not invented by ecologists, but basically was sort of borrowed as a concept from the sports. And here you see a stadium of football players, or what is it, baseball, whatever. The idea is that if you're a sports team, you do much better in your home stadium than you do in another stadium, because you are used to the environment, you're sort of adapted to the stadium that you play in. And this is not only happening in the soil, it's also happening within your own gut. So each of you eats food, and this food is basically, your microbes are adapted to break down the food that you take in. And as such, everybody of you has a different microbial community in their gut that's specialized to break down what you eat. And so that's also going on in the soil, it's going on in your body, so it's basically going on in life. And it sort of supports the idea that local nutrient cycling is very important, as we already know. You don't want to transport a lot of things far, but also by decomposing material locally, you may profit from your adapted soil community, your adapted microbial community in your gut, and nutrient cycling can be much more efficient. So this is going on in nature, and we're finding more and more evidence for this. But the question now is, can we also apply this in agriculture? So in current agriculture, plowing is going on, crops are harvested from the fields completely, and there's not a lot of material left to decompose. And as such, decomposer communities do maybe not play such a big role in current agricultural practices. However, you need to get your nutrients from somewhere. So farmers know this very well, of course. So what they do is they apply fertilizer. It's an external input into the system. And this is a very old commercial, and actually it says, put fertilizer on your land and it will double your crop. And farmers do that for a long time, and they still do it. And they apply fertilizer in all sorts of forms. It can be liquid, like you see here. It can be in different types. And it can be on a very large scale. It sometimes even happens before a crop is on the land. But the idea is this is still an external input. It's quite a huge input. It's expensive. And also it becomes scarcer over time. So I think if we look into these natural ecosystems and the evidence that we found from that, we maybe have to sort of focus more on the local nutrient cycling. So put in what was growing there, decompose it, and use the nutrients that come from there. And people start thinking about this already quite a bit, and there's different things that you can do. And one of the things that is done already is like reapply crop residues. And this is probably for different reasons, but one of them is to sort of stimulate the local nutrient cycling. So the valuable nutrients inside those residues get decomposed and become available again. Another thing what you can think about is put different crop varieties on your land. So this is an annual wheat. But there's also perennial species that stay on the land much longer. And they actually have the chance to grow somewhere for a while and sort of build up a decomposer community that is adapted to their own sort of species. So we know quite a bit about this and about the ideas from nature, but we never really looked into decomposition processes and Homefield Advantage in agricultural systems. So what we really should do now is open up the soil and see what's going on inside and see if decomposer communities in agricultural systems can actually adapt to the resource that they're fed with and if this will optimize local nutrient cycling. And we need to ask questions like, what do we need to put in? How much material do we need to put in? Can we actually modify decomposer communities? And does that benefit agricultural systems and nutrient cycling and crop yield? And what sort of crops do we need and when do we need to harvest them? That's all sort of questions that we do not know how that affects the decomposer community. So if we do focus on this and if we find out that nutrient cycling can be modified and optimized, we actually may have a much nicer agricultural system that profits from local nutrient cycling and will be a nice home for our decomposer communities. Thank you very much.